The waste management, it contains 7 R's actually.
What intrigues me specifically is the term waste valorization. Usually it's either management or recycling.
You can consider this waste valorization as the route for the conversion of waste to wealth.
So that's sort of Pandora's box for the chemical engineers, isn't it? Those who are wondering that chemical engineering is dead, for them, once again, the Pandora's box is here. Hello, welcome to our very first episode of the podcast, the Sustainability Conundrum. And today I am very happy that we have our first guest with here, and that's none other than our very beloved Professor Dr. Ranjana Chowdhury, aka the reaction kinetics queen, as we say with respect to her. And welcome to our podcast, madam.
Thank you, Vishwajit.
So as we will go through our podcast, and we will be looking into different aspects of sustainability, and as you all know that the theme of this season, or our first season, is electronic waste and EPR. But before we get to those, we are trying to set the tone for the rest of the podcast series by going through a little bit deeper with the different aspects and different angles of waste management. And there are different other terminologies which are associated with the waste management. So from that angle, my first question to you would be that there are different terminologies like waste management. Some people are saying waste valorization, and recycling, waste recycling, that we hear all here and there. So could you please explain this to our audience, that how they differ from each other, and how they differ from the traditional waste disposal methods?
I can say that waste management, if I consider it to be a very large set, then this recycling, that is the waste recycling, will fall as a subset in it, and waste valorization is another one, but a special one. And what I can say that the waste management, it contains 7 R's actually. That is, one thing is you can reduce the waste, amount of waste, and that can be done in different ways. So that the 7 R's which are involved in waste management are, first one is refuse and reduce. That is, if you reduce the consumption of the products, then automatically there will be a reduction in the waste generation. So these are the first 2 R's. And then comes the repair as well as reuse. That is, reuse means the product, so the shelf life of the product should be elongated. So you should use the product as long as possible, and that can be done through repairing also. So these are the next 2 R's. So then these 4 R's are completed, and then comes the repurpose and recycle. So what is repurpose? That is, you can use the waste for some other purpose other than this product, and also you can, so as the product reaches the end of life, then what you can do is you can recycle the materials which are there in the product for the production of this product and so on. So, and next comes the last R is the recovery. So recovery means you can one way of recovering something from the waste is to generate energy. So the very crude way of using the waste or to recover something or recover energy is to incinerate, but that's not a very good way, as you know, and I can elaborate it further in this conversation, that why incineration is not a good one. So it is a direct thermal process, but during this incineration there will be the emission of other gases and so on, which will pollute the environment. So that way incineration is not a very good option. So there are other ones, and there comes, I can again, another one which you were indicating was waste valorization. So by waste valorization, you can do many things. So using different conversion processes like thermochemical ones or biochemical ones, you can generate energy, as well as you can also generate a wide spectrum of chemicals which can further be used. So here you are not just recycling it, but you are generating something else, and that's the valorization thing. And under this purview of valorization comes different processes like there's, as I have just told you, that is thermochemical and biochemical. So under thermochemical comes this gasification, pyrolysis and so on, and under biochemical ones you can consider this this fermentation and all, both aerobic and anaerobic and so on. So that's the thing. I think your question has been answered.
Yes, truly, and since our audience is both technical and non-technical, I guess that's sets the differences about these terminologies and how they should be looked at. And what intrigues me specifically is the term waste valorization,
Yes.
because it's usually not used a lot of times. Usually it's either management or recycling. So from that perspective, with Madam, you have 30 years of experience in this
Yeah.
field. So what inspired you in this journey of waste valorization?
So you can consider this waste valorization as the route for the conversion of waste to wealth, because you are generating some energy sources, as well as you have the opportunity to convert it to some chemicals and so on. They are having different uses. So that way it is unique. This is not just recycling. So when you are talking about recycling, you know what to do. That is, you will use these materials for the same product, but here you are generating new products. So there are lots of scopes, and I can tell you that if you say if you go for gasification, then you can generate from this particularly the carbonaceous waste, you can generate syngas, which is a combination of CO, that is carbon monoxide, and hydrogen, and this syngas can further be converted to oil, fuel oil. So from the solid waste you can generate oil, this fuel oil, which is having tremendous demand due to this automobile industries and so on. And again, if you consider pyrolysis, then through pyrolysis you can generate this. So at least I can explain the process of pyrolysis. Through pyrolysis, we can generate some pyrochar, which is a solid product. Then we can generate simultaneously, we can generate pyro oil, which can further be used for the generation of fuel oil, and also it will produce some pyro gas. And there we are having different gaseous components like CO, like this carbon monoxide, hydrogen, methane, so to some extent ethane and so on, which are having heating values. So this gas can further be used and so on. So there is the enormous scope, and the char which has been generated through this pyrolysis, they can be used for different purposes, like you can develop nano adsorbents for water treatment. You can also use it for soil amendment. So that way this carbon sequestration is addressed and so on. So there are lots of scopes there. And if you consider these biochemical routes, again you can generate different fuel components like this alcohols and so on, and also some fuel additives, which I also looked at, like there's platform chemicals and so on. So that way, I think I should say that the opportunity is enormous and one should look into it also.
So that's sort of Pandora's box for the chemical engineers, isn't it?
Yeah, I think so, because most of the processes are associated with chemical engineering. So you have to know the chemical, this reaction kinetics of all these reactions which are involved in this conversion process, and with the knowledge of these kinetic parameters which you have determined, you can design your reactor, and once your reactor is successful in lab scale, you want to go for this large scale one. That there is another tool we use is process modeling, which is done by the use of the software like Aspen Plus and so on, and using these you can have the idea for this large scale plants. So that way you can have one strategy for this waste valorization. And that's the thing which triggered me to go into the research of waste valorization.
Well, that's excellent to hear from you, and honestly, and that is something, I mean, it's similar that also inspired me in my journey, because believe it or not, she was my PhD guide, and I'm very happy that she agreed to do this with me.
I'm happy to have you also. Yeah.
So I'm moving forward to the waste valorization part. Now, waste biomass valorization has enormous opportunities. It's a very growing field, I see.
Yes.
And could you share some innovative ways that it could contribute for a more sustainable future?
Yeah. So if we look at our country, like India, so the amount of this biomass which is getting generated, particularly through the agro industries or agriculture, this is about 150 MMT, that is million metric ton per annually. And there is a demand for energy, and there is also some challenges for this energy transition. So decarbonization, everyone is talking about decarbonization of energy sector and so on. And so if you can use these biomass resources for the generation of this energy, then as they are produced, they themselves are produced through the photosynthesis. So they have already absorbed CO2 from the atmosphere, right? So if you can use this resource for the energy generation, so you are one step forward with respect to the conventional ones. So conventional ones means the petrofuels, and but it's not a very easy task, right? And because what is there? This is what are actually these biomasses. They are the combination of cellulose, hemicellulose, and lignin mostly, right? And if you think of converting them in the biochemical route, then none of the microorganisms can take up this cellulose, hemicellulose, lignin. Particularly the lignin itself is very recalcitrant in nature. So you have to go for some pre-treatment steps that can be done through using dilute acids and so on, by the use of some metal chlorides and so on. And because the microorganisms can take up the sugars, mostly the hexose sugars, which are glucose and so on, and the pentoses to some extent, like xylose, arabinose and so on, they can convert these. So through these processes which I have just mentioned, these pre-treatment processes, you can convert this cellulose, hemicellulose to glucose, then arabinose, xylose and so on, which can again be taken up by the microorganisms to form the alcohols and so on. And these alcohols, that there is a mandate from the government of India also for the blending of ethanol with petroleum. So you can generate ethanol, but ethanol has got some difficulties because it is hygroscopic in nature, and particularly during this humid weather, ethanol will take up the moisture from air, which is detrimental for the automobile engine. So you can also think of generating the higher alcohols like hexanol, butanol and so on, and they are totally hydrophobic in nature. They will not catch moisture from the atmosphere, and the blending with the petroleum, or the, what we say is gasoline, that is very nice. So you can also generate those, and these are the things which are applicable when the lignin content is not very high. So I can say that when the lignin content is less than or equal to 10%, you can think of these biochemical routes. But if the lignin content is higher than this, you should not go through these biochemical processes, because then you have to invest much in the pre-treatment process, and even then the lignin will remain unchanged almost. So to take care of these, you can use the thermochemical routes like gasification and pyrolysis, which I have just discussed.
Yes.
So if you go through them, then lignin will not make any problem. So everything, that is cellulose, hemicellulose, lignin, everything will be converted, and you can have all the gases, and then if you like, you can convert these gases to this oil and like that. So you have this scope. So there are lots of potential in the valorization of biomass, that I can say.
So if I take it, if I take away from this from a common layman's term, so lignin must be the fibrous part of the things.
Actually, lignin is responsible for the binding of these other molecules, these carbohydrate molecules like this cellulose and hemicellulose. When we look at the 3 parts, plant parts and so on, lignin actually bind them together. Because what we see is the combination of all three. That is cellulose, hemicellulose, lignin, everything is there. So lignin binds them together. It's very, very essential. Lignin can again be converted to different phenolic compounds and so on. There are also lots of scopes for this lignin. And also you can, with this biochemical plant, you can attach another power generation plant, where you just generate power from the residual lignin which you are having. That's another scope, but you can also convert them to other very, very valuable chemicals.
So yeah, one thing you mentioned about the butanol blending, I think that's a policy gap. I'll come to that later. And those who are wondering that chemical engineering is dead, for them, once again, the Pandora's box is here.
I don't think that anyone thinks that chemical engineering is dead.
But personally, I have faced a few, so I just put it out there in that way. But yeah,
I have to identify them.
That's a completely different agenda. Absolutely, that's a completely different agenda.
Yeah.
But coming back to the two technologies you have mentioned twice or thrice, that the pyrolysis and gasification, and these are often seen as the transformative technologies for waste valorization or waste treatment. So could you explain the role of these technologies for sustainability of the waste valorization processes? And specifically, if we focus on, you have mentioned biomass already, if you can elaborate a bit further, and as well as electronic waste, because I mean both of these are different in nature.
Sustainability, then I have to explain what is sustainability and like this. So sustainable development was first coined in 1987 actually, and that is a development which meets the need of present generation without compromising the ability of the future generation to meet their need. That is the resources, the conservation of resources or the slowing down of depletion of resources. That's the thing which is there in the term of this sustainable development. So by this two processes which I have just described, isn't it not clear that they are forming? So through both these routes, some other this energy sources, chemicals, these are generated. So the overall natural resources are concerned that there is a slowing down of the this natural depletion of natural resources. So that way they are, I think, they are guaranteeing, or they are taking one step forward in this direction. And the next question you have asked, that is whether we can also use them for e-waste and like that. So my question is yes and no both, right? Because e-waste, when we look at the e-waste, then these are mainly the things which are coming into our mind. These are the printed circuit boards, which are very, very skeletal and the vital components of this electronic waste. Now they have this fire retardant part. So there are mainly two types of this fire retardant polymers or FRPs are used. So here one is FR2 type, another one is FR4 type, right? So and they are polymeric substances, and they have the fire retardant in them. So like many of them are brominated substances. So if you do your pyrolysis or the gasification at a high temperature, higher than this 400 or 450 degrees Celsius, then there will be the chance of emission of dioxin and so on, which are not totally detrimental for human health. So you cannot choose that temperature, which you can do in case of biomass. That's not possible in case of e-waste. So there is a limit for the temperature when you think of valorizing e-waste through these routes. So that you should keep in your mind, that I cannot go beyond some limit, this temperature limit, and where these hazardous substances are emitted, which I cannot do that. I cannot do anything which will harm the environment, which will harm the human health, which will harm the health of other beings which are other than these human beings, other species and so on. So I cannot do that. So there is a temperature limit, and with this you can think of using these technologies also for the valorization of e-waste. Like when you valorize e-waste through this, particularly if I think of this use of pyrolysis, you will see you can generate the polymers. They will actually, during pyrolysis, there will be generation of volatiles, and these volatiles, some of the volatiles are condensable in nature and some volatiles are non-condensable in nature, and we call the condensable volatiles as the oil part and or the liquid part, and the non-condensable volatiles as the gas part. So when we are going for the this pyrolysis route for e-waste valorization, then you can generate this oil. These are phenolic compounds, and then you are getting a very good quality oil. And not only that, in the this FR2 or particularly in FR4, there is metals are there, copper is there, and in the soldering is there, and on the PCBs, so different precious metals are there. You can recover those metals. And not only that, in case of FR4, there is a glass fiber part which will remain intact, and you can use it either for this particular purpose, that is for the production of this electronic materials, or you can also use it for other purposes. So you can have, or after pyrolysis, you will get the oil part, you are getting the metal part, you are also getting back this glass fiber part, which is beneficial, I think.
Okay, so before I pitch the next question to Madam. Let me just tell one thing I already mentioned in the previous question about electronic waste. So to our viewers, let me just clarify this to you, that electronic waste is basically end of life electronic gadgets. For example, a broken mobile phone or a broken TV or broken laptop, or that is not operating. So those are basically electronic wastes. And with Gen Z, I believe they already know what e-waste is, because not to blame them, but they are generating the high amount of electronic waste with respect to mobile phones. Well, I'm no different from them, but in coming to the point of electronic waste, and it is one of the fastest growing waste streams globally, and
Yes.
apparently this is one of the biggest reasons of maintaining the style statement with different versions of mobiles or laptops and whatnot. So what are the biggest opportunities do you see in valorizing electronic waste rather than going for traditional mechanical recycling?
That I think I have already answered in the previous question, that there are scopes for this valorization of e-waste to get other products, like, and also their components. So like oil, what I mentioned, that through pyrolysis you can also generate this fuel oil. So fuel oil is not, it will not be used for recycling. It's a new material which you are generating. So that way there is enormous scope for valorizing e-waste also. When you were mentioning about this Gen Z, this consumption of or intern generation of e-waste, so I was just looking at the statistics that it is 2 MMT annually for India, and India is probably the 4th one or like that, after US,
and
China and Germany also.
Okay.
No, I'm looking at it, it is after Germany.
After Germany.
It is India. Its place rank is very high in US generation that way. So there is enormous scope, yeah.
And from coming from that very same perspective of valorizing electronic waste, so in what I believe, in my opinion, correct me if I'm wrong, that there exist the opportunities. Again, the Pandora's box is there, and I think we need to delve much deeper, that what are the other aspects we can look into. For example, you mentioned the recovery of glass fibers. So what further routes can be taken to purify them, or the metals that are recovered? So that should be different type of metals.
This leaching can be done,
and all these
also
other
bio-leaching and all this. These are there, and not only that, during gasification, if you gasify, because there are lots of metals there in the e-waste, so that the chemical reactions are accelerated by the use of metal catalysts. So they also act as the catalyst. So you don't have to add catalyst additionally. They are there itself in the e-waste. So that way it's advantageous.
So anybody looking for research gaps, just rewind and watch it again. And before I go to my next question, like, there are people actually who are very much interested in working in e-waste. So I'll just play a small clip here, and I'll show. I mean, people are really interested in researchers specifically. They're interested in working in electronic waste. Is sustainability?
Yes, I do.
Can you describe it in your own words?
Well, according to me, sustainability is a process which goes on continuously over time.
So, do you think there is a discrepancy whether it can be achieved 100% or not?
Think anything is perfect in this world, so it cannot be achieved 100% always.
Great. And do you know what is electronic waste?
Yes, I do. I know it.
So, do you know how to dispose it properly?
I actually look for recyclers to dispose the electronic wastes, not motorcycle.
But you don't get one, right?
Yes.
So, at least you know about that. So, I see you were a researcher. So, are you doing any research currently on e-waste?
No, not right now, but I'm interested to do in future if I get a chance to do so.
Thank you so much. Okay, coming back to our next question, EPR, or extended producer responsibility, it is one of the most talked about policy tool. in addressing the e-waste crisis in our country today. And I know it's a Western concept that we have borrowed, or at least conceptualized or morphed it according to our needs. So what's your view on it, how it can tackle the e-waste?
No, actually, Government of India has put this e-waste management rules in first in 2016, they amended it in 2022, then again in 2024 they have amended, and yeah, this is very much welcome actually, because who will take the responsibility of e-waste? You cannot dispose it or you cannot put it to these corporation people, what they will do with it. So that way it's very good endeavor from GOI, and this is EPR, what you have just mentioned. This is extended producer responsibility. So the producers, not only producers actually, they what they are mentioning is there must be some PIBO registration, that is producers, because for this let's take the example of computers and so on. So many of them are imported ones. So there is a scope for registration by this PIBO window, that is P means producer, I importer, BO is the brand owner. So there is a scope for registration by this PIBO, and they will take the responsibility. They will channelize the e-waste, that is through their collection, through their transportation, and they will give it to the registered is very important for this refurbishment or recycling, all this, that is also this dismantler, they must be registered ones. No one anyone say I want to do it or you want to do it, that's not permissible. So they must be registered ones through the CPCB, that is this Central Pollution Control Board. There is a scope for this registration, and also there is very much accounting is there. Also this environmental audit, because you cannot do this dismantling or recycling or refurbishment anywhere. So the facilities which are to be used, that will be audited, the environmental audits will be done by CPCB. Then only they can do this thing. And not only that, I was looking into these rules, and like this, they are mentioning that they can store, because there is a question of after collection they have to store it.
Store it for some time.
So the storing can be done only up to 180 days.
180 days, yes.
Maximum. Only when you want to go for some new methods like this, not only recycling but this valorization and so on, you can take the permission. And if that is the case, then you can go up to this 365 days, that is 1 year. That is permissible. But it is our hope that it will be followed. And it is also mentioned that these who are the these collectors, who are the recyclers and so on, their numbers, everything, their contacts, that should be there. Otherwise a consumer, how would he or she know where to give and what to do? Right? That should be mentioned also. And that, I think that those will come up in a very near future, and we will be benefited. So I am very much in favor of EPR, which they have proposed or they have put into the rule.
So it actually helps to channelize the material flow as well. And I guess we need to give EPR a little bit more time to mature, because it's very new.
Any new process takes some time to come into this being. So it's there. Some time will be needed, but it will be there, I think.
So yeah, with with EPR, I guess we have to give it more time, and we have to support the ways our government
It's already there. It's already there. They
Yeah.
have mentioned. They have
They have-
framed the rules and
Yes.
everything.
And moving to my next question. So, as we have been discussing a lot about waste valorization, and you have already discussed these technologies, so I guess it's partly answered, but I'll put it in a different way, that how this contribute. I mean, you have already mentioned about the broader sustainability goals, but if I look at the context of circular economy specifically, how
No, if you think of the sustainability development goals, SDGs, these waste management themselves are directly related to some goals.
some goals, yes,
Yeah,
there are already
they are,
5 or
yeah.
6 goals that is there.
Yeah, that is goal number. If you look at this, goal number 3,
3.
that is healthy and healthy lives for all and well-being.
Well-being.
So, if the management of waste is good, then this will be satisfied. So, directly it is this SDG 3 will be benefited. Okay, and then comes the SDG 6, which is nothing but clean water and sanitization. So, if the waste management is good, then the water contamination will be less, and overall this clean, you can ensure this clean water, the usage of clean water, and also this sanitization, right. Then comes 7. 7 is affordable clean energy. So, affordable, as I have just mentioned, that during valorization, what you are doing, mainly you are generating some new sources of energy, and which and then particularly for if you look at biomass, then the decarbonization is happening and like that. So, that way this goal number 7, that is addressed, right. Then comes goal number 11. Goal number 11 tells you about sustainable cities and communities. So, sustainable, when you are tackling the waste of a city in a very good way, the motto will be the sustainable, must be at least more sustainable.
More sustainable than
right. Then comes the responsible usage and production. So, when you are, as I told you, that waste management, the first 2 R's are reduce and refuse. That is, you will not waste. Sometimes we buy things which we do not need. So, that tendency will be dropped, right. So, that way it is also addressed. So, this good waste management will ensure this goal number 12 also. Then comes goal number 13. Goal number 13 is associated with climate change. So, that is again associated with the reduction of this CO2 emission directly, because most of the major greenhouse gas is nothing but CO2, which is generated by power sector and also most of the industries. And if you can decarbonize to some extent, say, then you are also addressing that. And then comes goal number 14, which tells us about the marine life. So, if again this water, clean water, and this one is related, because the chance of contamination of water bodies will be much less. So, the life under water will be saved to some extent. So, that way it is very, very important actually. And there is another part, I think, of your question, if you can repeat.
It was like what particularly in the context of achieving circular economy, how?
Yes, circular economy means this product and nothing is, no material is actually waste. The basic concept of circular economy is this, and product and waste will be in circulation. Right. So, there will be, when you are using less, that means there will be chance of sharing, there will be chance of leasing something. So, one can borrow, and a group of, instead of a particular person, one group can use. Thereby also there will be reduction in using product, Then comes this, you have the scope for repairing, you have the scope for refurbishment, also you have the scope for recycling and so on. So that way, that is the thing which is also in you know this this green economy and all this, these are being designed. And another thing which is very important is the packaging. Also, not only if you think of electronic products, most of them are packaged. So that is another burden actually, not only the e-waste, the packaging materials which are associated with them, they are also very, very important. So in circular economy, there must be something by which you will protect or you will slow down the depletion of natural resources. By using, reusing and recycling and everything, you should do whatever you can.
Yeah, just to carry forward what you mentioned about circular economy, I think it's already there in our culture. We have been seeing our grandmothers.
In Indian culture.
In Indian culture, exactly. Because
it was there, I should say, but nowadays it's almost vanishing.
So,
but it should again come.
It should again come back. Yeah. So, I mean, just don't throw away after you finish that bottle of jam.
Yeah.
I mean, just peel it off and put some.
After end of life, you use the materials in it.
Yes,
maybe absolutely. Your product has reached the end of life.
End of life.
But there are materials which are there in your product, so use them also.
Exactly. So, my next question is somewhat linked to the practice of the waste valorization. So, what we see basically is people more concerned about, mostly industries concerned about waste management in general, or they are promoting recycling and different strategies, policies, etc. But what barriers do you think are there, the major barriers in scaling up this waste valorization practice, and what does the roles industries play here to make them more mainstream?
Actually, I should say that what I also mentioned earlier, that most say in academia, we are doing this R&D studies, and that is in lab scale. Maybe we are getting some success, and most of the R&D works are funded by government bodies, but if I have to prove it in large scale, then the industries should come up. What is there in these developed countries? So they inspect this when they just notice some prospect in any project, they take up, and they themselves offer the opportunity to test it in pilot scale and like that. If the pilot scale testing has to be done, that's not totally possible in the academia. That's not possible.
No, it is not.
Okay. So the industries themselves should come up, because in industries they are usually, there are many exceptions, but they are usually very satisfied with the processes which they are using, which they are following, particularly in Indian industries. So that mind block should be broken. So there are some newer things which may come up, and they should also encourage them. And to do this, they should also give some, either some fund, not only fund, actually they should give the opportunity to use their pilot plants for the testing, right? So, and that will actually accelerate the implementation of these new processes which are already tested in lab scale to be used in the large scale. That's there. I think that will be, there. So many industries are also coming up. Nowadays it's happening. It will be more in future, because in Western, if you look at US, many of the labs in academia are dry labs. Yeah. So they do research, but all the experiments are done in industries.
Right.
Okay, so there must be some journey hand in hand. Academia and industry. This amalgamation is very important for any new technology to be successful. It's a must for any process, any new process. It has to be actually the industries must be open for the new processes, and they will be, I think, because there are mandates from the sustainability aspect and like that. So they are coming nowadays. They are coming up.
I think the entrepreneurs are much more interested in these things because
Yes.
we also
But
found some episodes of Shark Tank specifically on sustainability and all this stuff.
yes.
So I think that
But the resources are very limited.
limited, yes,
So the large industries should come up. Yeah.
That at least the ball has started to roll. I guess.
Yeah, it has started. Yeah, that's a very good sign that it has started.
Okay, so we have come towards the end of our first episode. And my last question to you is that what are your thoughts about our podcast, the Sustainability Conundrum, and what's your message to our viewers?
It's the title you have chosen is good, but I don't think there is any confusion actually. It's not, sustainability is not any concept which cannot be, I think, foreseen or whatever, because this is a concept which is needed. Maybe it is one concept which is very idealistic in nature. It may not be reached 100%, but if you just follow this path, because when initially the word sustainability came into being, it was the relationship. It was for it was to reconcile the relationship between the economic development and the protection of environment, and it was very much concerned about the relationship between intergeneration, that is present generation and future generation. And afterwards, when UN put forward this SDGs in 2015, that is intrageneration, and that is needed, because if you do not follow it in present generation, then it will never be successful. So you should accept the fact that human beings have already done lots of detrimental things to the environment. It has overburdened, so they should be cautious enough to use the resources. So there is no confusion actually, and it is, I am very optimistic about this. That's my view. Obviously the title is good.
Ladies and gentlemen, I am tonight's entertainment. I just kicked out the other guy, and I'm Dr. Very Strange, and I will be dealing with this portion, what we call it, the rapid fire round. So ma'am, are you ready? So
Yeah.
may I shoot the rapid fires at you? So the first question is, what's the one word that defines sustainability for you?
Hope.
Excellent. And biomass or e-waste, which has more untapped potential?
I think both.
Both. Excellent. What's the most innovative waste valorization technology you have come across?
Integrated processes of this biochemical and thermochemical goods.
Excellent. So what's your go-to source for staying updated on waste management trends? Is it books or is it social media?
Books, publications, journals.
And if I have asked you to choose between gasification and pyrolysis, which one do you think has a brighter future?
Both, it depends.
If you have to name one country leading in waste valorization practices?
Germany, Sweden.
And your favorite success story in waste management? Any of the case studies you would like to recall?
Generation of hydrogen through coupling of dark and photofermentation.
And one thing the world should stop doing immediately to improve sustainability?
Disposal of waste.
Next, the biggest myth about waste management you would like to debunk?
Not unnecessary.
So there is no myth basically. If you could invent one technology for waste management, what would it be?
Oh, there is no unique solution.
It has to be taken all.
Everything.
And my last question, if the Bhuter Raja would have been here and asked you to grant 3 boons on sustainability, what those 3 boons would be?
Protect environment, avoid unnecessary usage of products, And so buying flicks, honor other species other than human beings. They are the sharer of the planet with human beings.
Okay, so keep the magic alive in you, and with that I conclude the rapid fire round. Yes, so I'm very happy to hear about the optimistic sense, because I am also optimist towards sustainability, and through this we come to an end to our very first episode of Sustainability Conundrum, and I hope you have gathered enough knowledge from this discussion, where we tried to focus on different aspects of sustainability with high focus on waste management and waste valorization. Stay tuned for our next episode. And before we bid adieu, we have a small token of appreciation from Greenwaves Environmental Solutions. I'll be happy to present it to Professor Chowdhury.
Thank you.
Keep the sustainability alive in you. Don't forget to like, share, and subscribe.